Welcome to the DIY Honda Garage channel. The DTC P0172 indicates that the fuel system is running too rich, meaning there is an excess of fuel in relation to the air entering the engine. The Honda Civic models from 2016 to 2021 are equipped with sophisticated engine control modules, ECMs, that monitor various sensor inputs to maintain the correct air-fuel mixture for optimal performance. This error code typically points to issues with components involved in fuel delivery and mixture regulation. Running too rich can lead to increased emissions and poor fuel economy, and may even stall the engine. Identifying and rectifying this issue is crucial for both performance and environmental compliance. The following diagnostic process will guide you through troubleshooting this specific DTC. The P0172 DTC specifies a fuel system too rich condition, which signifies that the engine is receiving an excessive amount of fuel compared to the airflow. Key components involved in this condition include the fuel injectors, which atomize fuel into the combustion chamber for combustion, and various sensors such as the mass airflow, MAF, and AF air-fuel sensors that monitor the air entering the engine and the mixture's composition. These components are generally found near the intake manifold and in line with the fuel rail. If any of these components are malfunctioning or improperly calibrated, they can lead to an overly rich fuel mixture, adversely impacting engine performance and fuel efficiency, thereby increasing harmful emissions. Several possible causes could be at the root of the DTC P0172 error. Faulty fuel injectors may deliver too much fuel due to leaking or malfunctioning mechanisms, thereby enriching the fuel mixture. Contaminated engine oil can indicate issues with the engine that could affect its functioning. For example, oil might be mixing with fuel if injectors leak. Exhaust gas recirculation (EGR) issues may also contribute, as malfunctioning EGR valves could allow excess fuel into the combustion chamber. Additionally, malfunctions in sensors like the MAF sensor or AF sensors can erroneously report incorrect data back to the engine control module, causing it to miscalculate the appropriate fuel-air mix. Drivers may notice a range of symptoms associated with the DTC P0172 error. One primary symptom is engine stalling, especially during idling or when coming to a stop, caused by the miscalculated air-fuel mixture. Poor fuel economy is another critical symptom, since running rich consumes more fuel than necessary. Furthermore, increased emissions from the exhaust may trigger the check engine light and produce noticeable odor from unburned fuel, indicating that the vehicle is not functioning optimally. A rough idle where the RPMs fluctuate can also occur. These symptoms highlight the importance of diagnosing and rectifying the issue as soon as possible to prevent further complications and maintain engine health. The first step in troubleshooting the P0172 code involves verifying the problem at idle conditions. Start the engine and let it idle in a neutral gear with no load. Using the Honda Diagnostic System, HDS, check the values for AF, FB, or short-term fuel trim. The ideal value should be less than 0.80. If it is indeed lower than this threshold, it indicates that the fuel trim is too low, which will prompt you to proceed to Step 3 for further diagnosis. However, if it is okay, further review of onboard snapshots taken during lower AF/FB values are required in Step 2. This step is essential, as it helps validate the source of the problem directly at idle conditions. In Step 2, you'll review the onboard snapshot captured during previous diagnostic checks to gain a better understanding of the vehicle's performance. The snapshot should include parameters such as engine speed, vehicle speed, relative throttle position (TP sensor), and the accelerator pedal (APP sensor values. After documenting these parameters, when the AFFB was at its lowest, drive the vehicle under the conditions noted in the snapshot. While driving, monitor the AFFB values using the HDS again. If the AFFB stays below 0.80, proceed to step 3. If it has improved, the system could be operating normally, and further troubleshooting may not be needed at that moment. Continuing with step 3, let the engine idle again and gently pinch the positive crankcase ventilation (PCV) vacuum hose to check for its effect on the fuel trim parameters. With the hose pinched, the HDS should show AFFB values again. If the values remain below the 0.80 threshold, it means the engine oil condition is satisfactory, allowing you to progress to step 4 for further diagnosis. However, if the AFFB value is higher than expected, this may indicate contaminated engine oil, which should be investigated as it could be due to leaking fuel injectors or other issues. Proper engine oil condition is critical for optimal performance and longevity. Step 4 focuses on checking the EVAP, Evaporative Emission Control System, canister purge valve, which could be a contributor to the rich fuel condition. First, turn the vehicle off and disconnect the purge valve connector before removing the valve, while keeping its vacuum hose attached. After that, connect a vacuum pump gauge to the purge valve. Start the engine and monitor whether the vacuum pump indicates vacuum. If it shows vacuum, warmer climates can cause fuel vapor issues that enter the intake manifold, enriching the mixture. In such a case, you will need to replace the EVAP canister purge valve. If it does not indicate vacuum, proceed to step 5 for further investigation. In step 5, turn the vehicle off before performing a throttle body inspection to determine if any carbon accumulation might be affecting performance. This step involves verifying that the throttle body operates within specified values. If the test shows results that are outside the specified range, it indicates a blockage from carbon deposits. Cleaning the throttle body can help restore proper airflow and functionality. If the throttle body checks out within specifications, advance to step 6 to investigate the fuel injectors, which are often another underlying cause of rich fuel conditions. Proper maintenance of the throttle body is crucial, as it affects the airflow entering the engine. Step 6 focuses on checking the performance of the fuel injectors. Begin by turning the vehicle off, then switch to the on mode and clear the DTCs using the HDS diagnostic tool. Once cleared, ensure that all AC systems and electrical loads on the vehicle are turned off to ensure accurate measurements. Conduct the cylinder AF test 3 times, as indicated in the HDS. If any failures are indicated during these tests, you will need to replace all the injectors as a complete set to maintain consistent performance across all cylinders. If all tests pass, or neither pass nor fail is indicated, proceed to step 7 for further examination. In step 7, the focus shifts to checking the low-pressure side of the fuel system. Start the engine and let it idle, ensuring you monitor the fuel pressure while confirming that the AFFB remains 0.80 or less. If the measured fuel pressure is within the specified range established during testing, the low-pressure fuel system is not contributing to the low AFFB condition. If it falls outside this range, there could be issues requiring a replacement of the fuel tank unit. It's vitally important to establish the fuel pressure parameters, as they directly influence the fuel delivery to the engine, thereby affecting overall performance. Step 8 involves scrutinizing the high-pressure side of the fuel system. Begin by placing the vehicle in off mode. Then, switch it to on mode and clear any existing DTCs. With the engine started, hold the engine speed at 3,000 RPM without any load until the cooling fan activates. Then let it return to idle. Utilize the HDS to conduct the DI fuel pressure test, determining whether the readings come back as normal. If the readings are satisfactory, proceed to step 9. However, if they are not, this necessitates further investigation into DTC P0087 and DTC P0088 related to fuel pressure discrepancies. High-pressure readings are crucial for adequate injector operation and engine performance. In Step 9, any potentially problematic fuel should be addressed. Start by turning the vehicle off and draining the existing fuel from the tank. Refill the tank with high-quality, known good fuel to rule out fuel quality as a contributor to the issue. Once refueled, start the engine and allow it to idle. Then operate the vehicle under the same conditions where the AFFB read 0.80 or less. Monitor the AFFB values again during this phase. If they remain less than 0.80, it indicates that the fuel is not the underlying issue. If the condition improves, however, it suggests that poor quality fuel was responsible, necessitating further consideration for future refueling practices. Step 10 brings attention to the MAF mass airflow sensor readings, which are critical for ensuring accurate air measurement entering the engine. While idling, ensure that the engine coolant temperature is above 158 degrees Fahrenheit, 70 degrees Celsius, and the vehicle is in the appropriate gears as stated. Hold the engine at an RPM of 2,500 for a sustained 30 seconds to stabilize readings. After this duration, use the HDS to check the MAF sensor's value. It should fall between 4.1 to 5.7 grams per second, GPS. If readings are out of this range, inspect the assembly for cracks or damage and check the installation. If everything appears okay, but readings are still incorrect, replacing the MAF sensor may be necessary. The focus of Step 11 is on the A-fan sensor, which plays a critical role in regulating the air-fuel mixture. Start by turning off the vehicle, then replace the A-fan sensor, Sensor 1, with a known good alternative. After installation, restart the engine and let it idle before putting the vehicle through similar conditions as encountered previously at the AFAM fit threshold. Using the HDS, once again monitor the AFAM FIP readings. If they remain below 0.80, it indicates that the AFAM sensor was indeed responsible for the poor readings, necessitating its replacement. If the values return to normal, consider reinstalling the original AFAM sensor and proceeding to Step 12 for further diagnostics. Step 12 involves the replacement of the fuel injectors. Begin by turning the vehicle off and replacing the injectors with those known to be in good working condition. As before, start the engine and allow it to idle. Following this by driving under conditions that previously reflected the low AFFB reading. Carefully monitor the values using the HDS during this final check. If the AFFB values remain problematic, it confirms that the injectors were causing the low readings. On the other hand, if they restore to acceptable levels, then you would need to consider using a known good powertrain control module, PCM, for testing to ensure there's no other underlying issue affecting engine performance. In the final repair verification stage, it's paramount to ensure that all diagnostics and repairs have been executed successfully. Verify that any components identified for replacement, such as injectors or sensors, have been correctly installed and functional. Next, recheck the diagnostic trouble code DTC status using the HDS. Ideally, clearing the DTCs should return no new codes related to fuel system richness. Finally, a thorough test drive is necessary to assess vehicle performance under normal conditions. During the test drive, closely observe engine performance, aiming for smooth idling and consistent power delivery. If everything functions optimally with no lingering codes, the issue can be deemed resolved. To prevent a recurrence of the issues leading to DTC P0172, implementing a robust preventive maintenance plan is crucial. Regularly replacing fuel filters can help ensure clean fuel delivery while preventing contaminants from reaching the injectors and other key components. Additionally, using high-quality fuel that meets required specifications significantly enhances engine performance and minimizes the risk of clogging and buildup. Consider routine engine servicing, including timely oil changes and inspection of all fuel delivery components like injectors and sensors. Conducting these preventive maintenance tasks contributes to the longevity and efficiency of the engine, ultimately saving on long-term repair costs and boosting fuel economy. In summary, the DTC P0172 indicates an overly rich fuel mixture in the Honda Civic from 2016 to 2021, necessitating thorough troubleshooting to pinpoint the exact cause. Initial steps involve verifying idle conditions and reviewing onboard snapshots, moving onward to check components like injectors, fuel pressure, and MAF sensors. Each component plays a vital role in maintaining the proper air-fuel mixture necessary for optimal engine performance. Following the structured troubleshooting process ensures that all potential faults are addressed and repaired appropriately, contributing to effective long-term engine health. By implementing ongoing preventive maintenance measures, vehicle owners can significantly reduce the likelihood of similar DTC occurrences in the future, keeping their Honda Civic running efficiently. Please like and subscribe to the channel. See you next time.